Unit 1, Lesson 2. Okay, looking for adding, subtracting radicals, concentrating on the like term idea. So let's look at this investigation 1. So last lesson we verified the addition of radicals. Remember we talked about how you can multiply break them up, but you can't addition break them up. Remember the little property we looked at? So think about here as well. 2 root 5, sorry, now I'm all mixed up. Root 2 plus 5 root 2 is 6 root 2. So I want you to figure out, is that true? So use your calculator. Go ahead and just put root 2 plus 5 root 2. The calculator will give you a decimal. Just make sure that it's 6 root 2. Okay. So go ahead and just try all those actually. I'll go pause the video. Just go ahead and try all of them. 7 root 5 plus 7 cubed root 5 equals 14 fifth root 5. I want to look at all those and just see which ones are true or not. We'll come back. All right, so what did you figure out with the first one? Do they match up? Okay, second one. This one. Oh, sorry, second one's this one. You're correct. Second one. Yes. Third one. Fourth one. And fifth one. Right. We learned this one yesterday. Okay, we can't add them and then put them together. Okay, because they're separate values. Okay, good. So the thing you notice is, notice that all of these have the same radicand. Okay, and index. That's important because this one has the same radicand but different index. Root 3 and a root 2 are obviously different values, so you can't add those anymore. Okay, that's why this is wrong. You can't add indexes. That's just crazy. It's like adding exponents. Okay, can't do that. Okay. All right, and then that one's different radicands. Okay, so we already did this. So what's the rule for adding, subtracting radicals? What do you want to write? What do you want to say the rule is? Good. Common radicand and index. That sounds good to me. Anybody want to add to that? No? All right. So we'll say common radicand and index. Good. All right, let's do these next couple. Simplify the following. Express the answers as mixed radicals. So let's go and take a look at these. I'll go ahead and speed us through these because I think these are fine. We have an 8 root 7, 3 root 7, 5 root 7. Again, for me, how I do it, I think about that as 8x minus 3x plus 15x. And I just do like terms. So that's 5 plus 15, 20. They all have 7s. They all have index of 2. Part 2. All have radicand of 10. All have an index of 5. 18 plus 12 is 30. Minus 7, 23. Notice I'm leaving my answers as a mixed radical. Yeah, oh yeah, the index. That's important. Good. Thank you. 5. Gets hard to write small. I get shy. 5 root x minus 4 root x, just radical x. Don't need the 1. You can write it if you need to, but you don't need it. Okay, now look at these ones. We're with a little curveball at you. We just said, wait, they had to be the same radicand. I want you to look at these. Do these match up? Okay, are those true or false? So put those in your calculator, and I'll pause the video. Gabby, what did you think for the first one? Is that one good or no good? Is true? Oh, that's weird. They're different radicands. Mr. Banker's already lied to you. So we said this one's true. Is that just coincidence? We'll see. How about this one? True as well. 12 and 48. What's the deal? They're the same. Explain. Good. So let me see if I'm saying what you're saying. Once you divide out the perfect squares, they're left over at that same value. Okay, so for example, we know that's 4 and 3, right? This is 16 and 3. So 3 is what we care about. That's what matched. 16 times 3 is 48. And then you got the giveaway was, look, I kind of told you, it's going to be a 3. Right here. It's going to be a 2. 4 times 2. Okay, so let me just finish those real quick so you can see it clear as day. Root 2 plus 2 root 2. That's what root 8 is. So 1 root 2 plus 2 root 2, 3 root 2. This way comes out. Now, people mess this up all the time. If I pull a 4 out and there's a 5 there, what do? Multiply it by 2. So 5 times 2, not 4. 10 root 12. All right, we didn't do 12, 3. Okay, 10 root 3. Okay. 16 comes out as a 4. 4 times 6 is 24 root 3. 10 plus 24, 34 root 3. Okay. So what that is if you're just thinking, oh, cool, I just look at radicans and call it good, you got to make sure that your radicans aren't hidden. You got to make sure you can't simplify. Okay, they're not always going to be just super simple. Okay. Okay, complete these ones. We just did all that. So, yeah, sorry, I did all that up here for some reason. Wanted to make it look harder to see. So, we'll just go 2 root 2. We did 10 root 3 plus 24 root 3. Okay, we'll leave it at that. Okay, just a couple more examples, guys, and you guys have some time today. So remember, today's focus is independent. Okay, so it's kind of thing, if you have questions when you're working and stuff, kind of the social aspect's gone today. Okay, if you have questions, see me first. Okay, ask me, just raise your hand, I'll come to you. Okay, we're focusing on independent today. Okay, all right, here we go. Adding, subtracting radicals. So let's look at these two. Examples. So write each expression in terms of a single radical. Okay, so we got root 80, root 20. Well, root 80 I know breaks down to 16 times 5. I know that root 20 breaks down to 4 times 5. So now that comes out as a 4 minus 2. 2 root 5 is your solution. Okay, went a little fast there, so I'll slow down for a second, let you catch up. I broke them both down. I noticed they both had the 5 was the lowest. That caused them to share radicand and index, and I went minus from there. So do you think for checking your work on this one, can you put 2 root 5 in your calculator and then put root 80 minus root 20? So let me say that again. Can you put 2 root 5, see what that value is, and your calculator go root 80 minus root 20? Should they be the same? Yeah, we're still simplifying. We are not changing values. We are still simplifying. Because when you put the minus 20, you still are minusing something. So you're still minusing that value. All this is simplifying. Okay? Okay, the cube root 1. 8 times 10, 27 times 10. Remember, we like 8 and 27 because those are perfect cubes. 2 cube root 10 plus 3 cube root 10, 5 cube root 10 is where we're going to be for that one. Okay, I'll pause it for a second. I want you guys to take a shot at C. See how you do. I'll come check it down. Okay, so we're just going to break down C here. So 9 times 3, 25 times 3, and 49 times 3. So that comes out as a 3, 21 root 3, 5, 15 root 3, and 7, 14 root 3. So 21 minus 15 is 6, plus 14 is 20 root 3. All right. Okay, I'll give you a little more time to take a shot at the next one with the fractions. Okay. Yep, I know, you got scared, yeah? It's all right. Okay, so yeah, this one here, we're going to have 3s and 2s. Okay, so you're going to have an answer with 2 radicals, not going to have 1 anymore. Okay, So, and they threw fractions in, so they really went full throttle on you here. So 108, what's 108 break down to? 36 and 3. Okay, so 36 comes out as a 6. Multiply those, negative 30 root 3. Now, we know that 3 doesn't go into 8, so you're like, uh-oh, we have a problem. Mr. Love, you guys started saying, nope, I'm done. Okay, it's 4 times 2. The 4 comes out as a 2. 2 times 3 over 4. Don't forget your fraction multiplication, straight across. 2 times 3 is 6. 1 times 4 is 4. 6 over 4 is also what? 3 over 2. So it comes in, if you're really getting swimming here, 6 over 4 is 3 over 2. Okay, don't get lost. Stay with me. So we're 3 over 2 root 2. Okay, so yeah, root 3 root 2. Oh well, just keep going. 48, 16 times 3. 16 comes out as a 4. That makes these 4's cancel. So it's simply negative 5 root 3. If you want to see the fraction way, it's 4 over 1 times 5 over 4. See those cancel? But you can also go negative 20 over 4, which is just negative 5, if you want to do the long way. But it's just up to you, that's fine. And 25 times 2 here. The 5 comes out. Okay, 5 times 1/2 is 5/2. So we have 4 terms, 2 with root 2, 2 with root 3. So we can combine those ones only. Negative 30 root 3, negative 5 root 3. Negative 35 root 3. 3 over 2 plus 5 over 2. Remember, it's got a common denominator already, so that's good. 8 over 2, which is 4. And that's your simplified answer. Okay, remember, 3 over 2 plus 5 over 2. We're adding fractions there. That's common denominator. 8 over 2, which is 4. Okay, I tell you, when I go up here and I do the fraction stuff kind of fast because it's, no offense, you're expected to know those things, the fractions, I know. But just ask me to critique it or to go through it a little bit more. Like I said, really do it out for you. I have no problem doing that for you for a while. Okay. Got to get up to speed on our fractions, though. Don't be scared of them. All right, so let's go over this ugly one here together. So cube root 64 is nice because why? It's just 4. Cube root 64 is no break it down. It's a number because 64 is a perfect cube. So that's just 4. So that's just 4 over 8. Okay, 375. As soon as I see 375, to me, I think about 125, right? So we got 125 times 3. So this comes out as a 5. So it's going to be plus 10 cube root 3. Okay. What's that? Oh, yeah, 27 for the next one. So 54, the 27, we already did 54 earlier, so 27 times 2 there. The 27 comes out as a 3, which will do what? Cancel the 3 down here. You can multiply the 2 if you want. You'll have 6 over 3, which is 2. Okay, it's up to you. But the 27 comes out as a 3. You'll end up with this. 2 cube root 2. And the last one, 8 times 3. What's the 8 come out as? 2. There's also a 2 on the bottom, so it cancels. So only 2 we can combine is these two. 10 cube root 3 minus 5 cube root 3. So your perfect answer, and I'll stop and you can ask questions, is 1/2 plus 5 cube root 3 minus 2 cube root 2. That's your final answer. Why did I lose you? Did I lose you?
Not really.
Okay.
I'm just simple
Oh, okay.
skip steps.
Okay. All right. Well, like if you want me to line them out or lay it out, just let me know. Any other questions from that one? Okay. I'll probably say this 10 times a semester. Remember, if you're just writing down what I'm doing on the board, the problem with that is I know what I'm doing. Okay? It's really easy to write what I'm doing, but unfortunately I can't do that for the test, right? So make sure that if you're just writing stuff down and have no concept of what's happening, you need to ask questions, advocate, okay? Don't get far away from yesterday's spiel, okay? Didn't put that up there just for fun. All right, so make sure we're asking questions. Okay, one more example, okay? You can ask me questions during independent time if you'd like. If you're worried about now, write it in your notebook. Practice good habits. All right, now the applied part. They want you to put it all together, okay? I want you to put it all together. So they're just saying, what's the perimeter? They say, find the length of x. Oh, no, find the length of x. Okay, that's even easier. So what do we have to do to find the length of x? Yeah, Pearl?
You can split the two shapes, so you have like a square and like a rectangle.
Yeah.
And then do a root 2 plus 2 root 12 minus 5 root 7 minus 4 root 8.
Okay, good. So she said split into shapes. That's just how she's visually seeing it. I'll try another way. Do you guys see you have this whole side here, right? Okay, well, we only want this piece of it, and this is canceling this piece. So we're just going to subtract that to figure out what this is. Okay? So just keep that in mind. So while we do that, we go simply 8 root 2 minus 2 root 12. We know 12 can be simplified, so let's go ahead and do it now. 4 times 3. Okay, 4 times 3. Let's just do all these. 9 times 3, 16 times 3. Now, if you're really struggling with that perfect squares piece, guys, that just takes time. Okay, obviously I'm a math teacher. I've been doing this a long time. Instead of sitting here waiting for you guys to get them, I am doing them for you, but you'll recognize them as you go. Okay, the more you do them, the more you'll get it. So this will simplify to 8 root 2 plus, this comes out, so 4 root 3, and you go minus. Now put a bracket here because you're minusing this whole group, so you do need to distribute. 9 comes out as a 3, so it's 15 root 3. 16 comes out as a 4, so it's minus 16 root 3. Okay? So 15 minus 16 is negative root 3. So we're doing negative. So what's a negative negative? Plus. That's the challenge question today. Okay. And then for the decimal part, for part B, guys, you just calculate that. You can just put that in your calculator. Okay. All right. That's it for the lesson. Okay. Go ahead, Duffy. What do you got? 16. Over here? Oh, yeah. What am I doing? 16 times 3. I thought it was 48. Gosh, Lord. Good job, guys. That's all right. It's all right. This is 9 times 2. I saw 48 in my head, so that's why I did 6 times 3, and Duffy just caught it. So, yeah, that's why we're confused. That's fine. We can change these real quick. We're okay. That's actually good because now we have 2 pairs that match. So it won't be just one alone. All right, my bad. So that comes out 3, so that's negative 12 root 2. Is that better, Duffy? Okay. So let's get rid of this. Okay. Fix it for the video too, since we're recording the mistake, which is awesome. Okay. So these can't do anything. So what you got to do is 8 root 2 minus a negative 12 root 2. So that means plus. Okay. So that means you're going to do 8 root 2 essentially plus 12 root 2, so 20 root 2. And then you have 4 root 3 minus 15 root 3, which is negative 11 root 3. That should be it. Let me double check here before we close it off. Yep, 20 root 2 11 root 3. Sorry about that, boy Duffy. Thank you. All right, now we can stop it.